Okay, in this lecture we're not going to cover any new material, but we're going to do some much needed practice with the material learned in the previous lecture. Okay, so I have here some questions from the textbook. These are on page 323 and 324, numbers 11 through 15, okay? Now we're not going to do 13 and 14. But I am going to add part to question 12. Okay. Let's read the sentence at the beginning. The length of time a particular smartphone's battery lasts follows an exponential distribution, we covered that in chapter 5, with a mean of 10 months. And then it says a sample of 64 smartphones is taken. Okay. Number 11 says, what's the standard deviation and what is the parameter m? We'll review that and answer those questions. And then 12 says, what's the distribution for the length of time one battery lasts? We will also review that. Now I'm going to add this part. I'm going to say, what is the distribution for the average battery life of a sample of 64 batteries. Okay, we'll answer that, and then we'll do 15. Okay, so 11 and the first part of 12. In order to do that, you have to go back and review lecture 20. And in lecture 20, we had some information about exponential distributions. Let me remind you about that information. Here's a quick reminder. Exponential distribution, a continuous random variable that appears when we are interested in the intervals of time between some random events. For example, the length of time between emergency arrivals at a hospital, or in this case, the length of time that a smartphone battery lasts. It says the mean is mu equals 1 over m. Okay, we're going to need that formula to answer our question. And the standard deviation is 1 over m. And the probability density function, which is also called distribution, is m e to the negative mx. Now for our problem, we're told the mean. This is mu right here. There's a mean of 10 months. So mu equals 10. Okay? It says, what's the standard deviation? Okay, look down here. The mean and the standard deviation equal each other. They're both 1 over m. I don't even need to know what m is right now. All I need to know right now is that the standard deviation equals the same thing as the mean. And they told us that the mean is 10, and so that means the standard deviation is also 10. Okay? Now we'll do B. What is the parameter m? Okay, so 10 equals 1 over m, so therefore m must be 1/10. Okay, so that answers those two questions. What is the distribution for the length of time one battery lasts? Okay, that's right here, given to us right here. Okay, the answer is f of x equals 1/10 e to the negative 1/10 x. If you graph that, it looks like this. Remember, this is an exponential distribution, so if you have taken pre-calculus or calculus or something like that, then you might be familiar with exponential functions and the fact that they always follow this basic shape. Okay, now this is nothing new to us. This is just reviewing stuff that was found in lecture 20. Okay, now we're going to get into the new stuff. Look at the new part of question 12 that I added. What is the distribution for the average battery life of a sample of 64 batteries? Okay, so I want to remind you that the average of a sample is not called mu, it's called x bar. And what we learned in the previous lecture is that x bar has a normal distribution, and the question is, what is the mean of that normal distribution, and what is the standard deviation of that normal distribution? Okay, we learned that in the previous lecture. We learned that the mean of the sample averages is equal to the mean of the population. So in our case, that is 10. Okay, so let's put that up there. All right, in the previous lecture, we learned that the standard deviation of the sample averages is equal to the standard deviation of the population divided by the square root of the sample size. So in our case, that's 10 divided by the square root of 64, which is 10/8, which is 5/4, which is 1.25. I mean, so there's lots of ways you can write it. Write it however of those ways you prefer. I'm going to put 1.25, okay? Okay. So we're looking at a normal distribution with a mean of 10 and a standard deviation of 1.25. Okay, that's the answer for my additional question of question 12, the second part. Okay, I didn't write an equation for the distribution. I wrote its name. That's good enough. That's all we need. Okay, and I also drew a picture. All right, now let's answer number 15. What's the probability that the sample mean is between 7 and 11? What is the probability that the mean of a given sample is between those two values? The answer geometrically is the probability equals this area. Whatever this area is that I'm shading, that's the answer to number 15. Okay? Now, remember, when we look this up, we only have one normal distribution that we have access to, the answers. And that is the normal distribution with a mean of 0 and a standard deviation of 1. That's also called the standard normal distribution. Okay, so we are going to look up this area because we have tools to look this stuff up. And whatever that area equals, that's going to be the same as this area, which is the answer for our question. Okay, there's only one catch. What's the catch? The catch is we need to know these two numbers here. They're not 7 and 11 because this is a different distribution. So remember, what do you call that? You call that z-scores. Okay, so first let's find the z-score for 7. We go 7 minus 10 divided by 1.25. And we get negative 2.4. So that's this number right here. Okay, now let's find the z-score for 11. Okay, 11 minus 10 divided by 1.25, and that equals 0.8. So that's this number here. Okay. Now, almost done. I'm going to open my Excel program on my computer. And I'm going to type in, let me remind you the formula, I'm going to type in equals norm dot s dot dist parentheses 0.8 comma true. Okay, let me type that in and tell you what I get. Okay, I got 0.788145. Zero point 788,145. Now let me show you in the picture what that number represents. Okay, that number represents all of this area. Darn it, sorry. You're gonna have to wait a second while I redraw that again. Okay, there we go. So, all that bright blue area there that I just shaded, that's 0.788145. Is that the area I'm looking for? Not exactly, is it? I need to now take away this area here, the dark blue area. So I go to Excel and I type in equals norm s dist parentheses negative 2.4 comma true. Okay, give me a second to type that. And I get 0.008198. Now I take that the dark blue area that's in the picture right above, and I subtract that from the total light blue area, and let's see what we get. .779947. So that's our answer. Okay, that's the probability of a sample mean. So that means you grab 64 batteries, measure their battery life, and take the average. The probability that we get an average between 7 and 11 months is 0.779947. Okay? Okay, let's look at these questions. There's a whole bunch. We won't need to do them all because they're all the same. We'll do one for practice. Okay, these are right out of the book as well. So let's read the first one together. A population has a mean of 25 and a standard deviation of 2. So that's your mu and your sigma. Okay? Not mu x bar and sigma x bar, just mu and sigma. It says if it's sampled repeatedly with sample sizes of 49, that's your n, what is the mean and standard deviation of the sample means? So let me paraphrase. The question is saying this. If mu equals 25, sigma equals 2, and n equals 49, then what do mu x bar and sigma x bar equal? That's what the question's saying. Okay? And all of these 8 questions are saying the same exact question. Okay? I do want to point out something, though, that looks different. Look at this 125, it says. What is the mean? Don't worry about standard deviation right now, but just look at this. What is the mean of the sample means? Okay? Further down, they change their wording. Look at 30. It says, what is the expected value of the sample means? Okay, the answer is the same either way. And the answer is whatever mu is. So for 25, the answer, yeah, that's right. For number 25, the answer is 25. For number 30, the answer is 17. Because the mean of the sample means we write down as being the same as the mean of the population. Okay, and let me explain why again, because it's not a simple little thing. It can be. If, it depends on how much you want to get out of this class. If you just wanted to figure out how to do the problem so that you pass, then you just need to remember that mu x bar, you write down the same thing as mu. Same number. Okay. If you want to understand a little bit deeper of the reason why, then let me quickly summarize that again. Okay. The central limit theorem tells us that the expected value of mu x bar is mu. What that means is it means that mu x bar should be close to mu. And the more samples you take, the closer mu x bar will be to mu. That's what the word expected value means. The more samples you take, the closer it'll get. That's what the central limit theorem says. And then, in addition to that, we also have the law of large numbers, which says, additionally, the bigger each sample is, the closer mu x bar will be to mu. Okay, so mu x bar should always be relatively the same as mu. So therefore, when you're asked a question, what does mu x bar equal? You write down whatever number mu is. Okay? And you can, if you were actually a statistician doing this, you can ensure that mu x bar will be very, very close to mu by taking big sample sizes and taking many, many samples. Okay? All right. So let's complete 25. How about we'll do 25 and 30 both, okay? And all of these questions work the exact same way. So we'll do those two. Okay? All right, let's work it out down here. So they've given us mu is 25, sigma is 2, n is 49. Okay? What is mu x bar? So that one, again, very easy. It is, well, at least we write down, we expect it to be the same thing as mu. So in this case, that'd be 25. Okay? What is sigma x bar? Okay, the formula for that is sigma divided by the square root of n. So in this particular case, that would be 2 divided by the square root of 49, which is 2/7. Okay? So there's the answer for 25. Let's do 30 together. Here's mu. The population has a mean of 17, that's mu. Has a standard deviation of 0.2, that's sigma. Our sample size is 16, that's n. So what is mu x bar? It's 17. And what is sigma x bar? It's 0.2 divided by the square root of 16, which is 1/5 divided by 1/4, which is 1/20. No, sorry, that's not true. It's 1/5 divided by 4, I should say, which is 1/20. Okay? Which, if you want a fraction, by the way, that's half of a tenth. So that's 0. I have to think for a second. 0.5. There we go. There's 1/20. Okay. All right, so those questions are very easy. All right. Now I found in the book one other type of question. So let's look at least one of those. Okay, let's look at this question. There's several in the book that are essentially just like this. According to the IRS, the average length of time for an individual to complete their tax return is 10.53 hours. Okay, look at that. Average length of time is 10.53 hours. Okay, so this is mu equals 10.53 hours. Okay, the distribution is unknown, so x is distributed, we have no idea how. let's assume the standard deviation is 2 hours. I don't know where they are coming up with that assumption, but the point is that they are telling us to use 2 for sigma. Suppose we randomly, by the way, I didn't highlight it, that's right here. Standard deviation is 2 hours, okay? All right, suppose we randomly sample 36 taxpayers. So N is 36 people. Okay, so let's answer their 5 questions here. In words, x equals what? Okay, let's write that down. X equals the number of hours it takes. Now, this is the important part. A person. One single person, okay? To complete their tax return. Okay, now look at the next one. In words, x bar equals what? Okay, so listen carefully to the difference. X is the number of hours it takes a person to complete their tax return. X bar is the average number of hours it takes not a person, but 36 people to complete their tax return. You see the difference? So X is referring to singular people. X bar is referring to 36 people, because we're doing samples of 36. And there's also another word that's different. Do you see it? The word average is there. Okay. And by the way, let me point out again the difference between mu and sigma versus mu x bar and sigma x bar. Okay. Mu is the average of the x's. Mu x bar is the average of the x bars. And what are x bars? X bars are averages. So this is really important. This is the whole key. So mu x bar is the average of the averages. That's the whole key right there. Okay? The average of the averages. When I finally figured that out as a student, that's when this stuff started making sense to me. Okay? And same thing with the sigmas. Sigma is the average of the x's. Sigma x bar, oh, sorry, not average, standard deviation. Let me write it down. Sigma is the standard deviation of the x's. Sigma x bar is the standard deviation of the x bars. So that's the standard deviation of the averages. Okay? All right. Let's get back up to their questions up there. When it says x bar and then it's got that wiggly line called a tilde and then it's got some blanks, what they're asking us is, what is the distribution of x bar? Okay, now in the question it says, doesn't it say the distribution is unknown, right? But that's the distribution of the x's is unknown. They're asking us here in part C, what's the distribution of the x bars? Those are always normal with the average of, like I was talking about below, the average of the x bars. Okay, so what is that? The formula is that that's always the same as mu. So that's going to be 10.53. Okay, let's find the sigma of the x bars. The formula for that is sigma x bar equals sigma over the square root of n. So this will be, in our case, 2 over the square root of square root of 36, which is 2/6, which is 1/3. Okay, let's go ahead and write 0.3333 for that, okay? So there's our answer for C. Okay, now D. Would you be surprised if the 36 taxpayers finished their forms in an average of more than 12 hours? Okay, how are you going to answer a question like that? They're asking you for an opinion, right? But they want an educated answer. They don't want you to just say, well, yeah, I guess I'm not surprised by anything anymore. You know, they don't want you to say that. They want you to say, yes, I would be surprised, or no, I wouldn't be surprised, based upon this evidence. So what's the evidence? So here's what you do. Okay, for D. They're asking us this. I'm going to rephrase the question. The question says, would you be surprised if x bar came out to be bigger than 12? That's what they're asking. How are you going to make a decision of whether or not that would surprise you? It depends on what is the probability of x being greater than 12. That's the question you have to ask yourself. Okay, so you ask yourself, what is the probability of x bar being bigger than 12? Okay, so you do what? You find the z-score for 12. Z equals 12 minus 10.53 over 0.3333. Okay, give me a second to see what that equals. So that's about 4.41, let's say. So you ask the question, what's the probability that x bar is greater than 12? Well, that question turns into, what is the probability that z is bigger than 4.14? So I go to Excel and I type in equals norm dot s dot dist parentheses 4.14 comma true. Okay, so give me a second to do that. Okay, now I got the answer, but before I tell you the answer though, I want to point out something. When you do that, remember, it's always telling you an area to the left of your z-score, which means less than. So the number that I'm about to tell you is the probability that z is less than 4.41. Okay? And that came out to be 0.999995. That's what this area here is. 0.999995. So what is this area? That would be 1 minus 0.999995. Okay? Which is 0.000005. So now I think you can make an educated answer to their question. Would you be surprised if x bar was greater than 12? Now that you know the probability of x bar being greater than 12 is this number right here. That's a tiny number, right? So the probability of that happening is tiny. So would you be surprised if it happens? I certainly would. You see what I'm saying? So how would I answer the question? Because it does say, explain why or why not in a complete sentence. So I would say, I would be surprised comma, because the probability of that happening is 0.000005, comma, which is very small. Okay? Now, let's go to question E, and then we'll be done. Okay, I'm going to move this stuff down out of the way here. Okay? All right, question E. Would you be surprised if one taxpayer finished his or her form in more than 12 hours? In a complete sentence, explain why. Okay. I have mixed feelings about this question. Because on the one hand, they said the distribution is unknown. So on the one hand, I feel like, how are you going to make an educated answer when you don't even know how the individual times are distributed? Okay. However, if they force me to make an answer, I think I can still give an educated answer because of this. The average for one person is about 10.5 hours. The standard deviation is 2. So 12 hours is less than 1 standard deviation away from the mean. So it's not altogether that surprising if one person took longer than, well, what would that be? Let's see. 10.5. I know it says 10.53, but let's say 10.5 for right now. It says the average for one person is 10.5. If somebody took 12, that would only be 1.5 extra hours. Okay? So like I said, that's less than 1 standard deviation. So it wouldn't be that surprising if someone told you, okay, one person is going to take an amount of time that is not even a full standard deviation away from the average. Okay, that would not be that surprising. If it was 3 standard deviations away. So if it was like it took them 16.5 hours, then that would be surprising. Okay? But 1.5 hours, when that is less than 1 standard deviation, that's not that surprising. So how would I answer it? I would say, I would not be surprised because 12 is less than 1 standard deviation above the mean. You see what I'm saying? I hope that makes sense. Okay, so I think all of these practices that we did, some yesterday and then all of these today, I think those should set you up pretty good for answering your homework questions. If you need help with them still, then come to the Zoom discussion and I'll help you with them.